Okay, this section links to rates of reaction 3, looking at two factors, catalysts and surface area. Catalysts are chemicals that basically increase the rate of a chemical reaction, and they're very, very useful to industry. The key thing about increasing rate basically means if you use a catalyst, and we'll talk about some other key features of catalysts in a second, but if you use a catalyst, you maybe don't have to have the temperature as high as you would necessarily need it in order to make the reaction proceed at a fast enough rate. Catalysts are very, very specific, and that basically means that they will only work for maybe one or two chemical reactions only. Okay. You also need very, very small amounts. Very, very good if, for example, you actually want to save money again in industry. And the reason that a small amount is needed is that a catalyst is not actually a reactant, so it doesn't get used up, it's unchanged at the end. But what it does is it allows the chemicals to react quickly to basically produce a product. They can basically be reused. So only a small amount is needed because you don't have to keep on adding catalyst. It can be reused over and over and over again. For the higher tier, what a catalyst actually does is it lowers the activation energy. And when we talked about in the previous video about activation energy, what we're talking about is that's how much energy the particles need to collide with in order to basically react, to have a successful collision. So what a catalyst does is it lowers how much energy is actually needed for the particles to collide with before they actually react. Okay, so again, incredibly useful for industry. Don't have to have your temperatures as high, and basically you only need very, very small amounts. Perfect example in C2 is the formation of ammonia through the Haber process, and the catalyst used in that particular example is iron. Another factor is surface area, and this tends to be something that can confuse people. The two examples you will always get is linked to having the chemicals in a lump or basically having it powdered. So if we think about a lump, the only particles that can react are the particles on the outside, on the surface. So in this particular case, if we just take it from this particular area, what we're talking about is all the particles on the outside of that block are going to be able to react. If we then break it down into pieces, so the same area and the same piece broken down into 4 sections, we still have the particles on the outside that we originally had around the outside of the piece, but suddenly we have all of these particles exposed in the center, and that's a real positive. So powdered chemicals are better than having it as one whole lump, and it's all to do with the surface area. Because we have less particles exposed, okay, basically we have a small surface area. When you powder it, okay, you break it down to tiny pieces, suddenly you increase the surface area. A small surface area has less particles exposed. For higher tier, that's a really important word to include. And a large surface area has got more particles exposed. And those particles have the ability to react with whatever reactant you happen to have reacting with the solid. If there are less particles exposed, there will be less collisions per second. Don't forget per second. And if there are more particles exposed, there will be more collisions, again, per second. Okay, don't forget the per second part for both of those. Less collisions per second will result in a slower chemical reaction. More collisions per second will result in a faster chemical reaction.